Alright, we'll try and go here not too quick. I'll try and take my time, and I'll break them up into short videos. So I'll try and keep each one under 5 minutes. That way you can kind of just watch the section that you need. So problem number 1 is a statement of the irrational root theorem. Basically it's asking you if it knows you know it, because they give you an irrational root, which means just a solution of an equation, and we just have to remember that these things always come in conjugate pairs. A plus get how your book does it, we'll go B root C always comes with A minus B root C. So for our problem, 3 plus root 2 means 3 minus root 2. So this change in sign there always occurs in front of the radical part of your equation. Keep in mind this also happens with imaginary numbers. 3 plus 2i would have its imaginary conjugate 3 minus 2i. So these solutions will always be together. Number 2 is a little bit tougher. Find a third degree polynomial equation with rational coefficients of 2 and 3 plus I. And so right away we know 2 is a solution, 3 plus I is, and because of the previous problem, 3 minus I is also a solution. Okay, so with those 3 solutions, I'm going to put a new page in here, I hope. See if we can add a new page, because this one takes quite a bit of work. Let's see here, we'll add a new page just like that. Alright, so I'm going to take those 3 solutions, 2, 3 plus I, and 3 minus I. And I'm going to write the factors that they came from. So if 2 is a solution, x minus 2 is a factor. If 3 plus I is a solution, x minus the quantity 3 plus I is a factor. And the same thing goes for the conjugate, 3 minus I. So those are our 3 factors. Now we just have to multiply those 3 together, and that would give us the original polynomial. Now when I multiply these 3 together, I'm actually going to do those 2 factors first. So the x minus 2, I'm not going to keep rewriting it. That's just sitting out front. And I'm just going to work on these 2 factors that come from the conjugate. The first step in multiplying those is I've got to get rid of this inner set of parentheses. So I'm going to distribute this negative in front of it. And so this first factor becomes negative 3 minus I without the parentheses. And the second factor becomes x minus 3 and then plus I, because you distribute that negative to the negative, giving you a positive I. Now this is just another big distributing problem. I guess I'll pause right here, and I'll pause here and go to my class. Be right back. Alright, so let's continue on. Now we're going to distribute this x to each one of the terms in the right-hand polynomial there. So we take x times x and we get x squared. Take x times negative 3, we get negative 3x, and x times positive I, and we get xi. And you could put ix or xi. Next we take the negative 3, we're taking the sign with it, and we're going to distribute that to each of the terms in the other polynomial. So we get negative 3x, and we get negative 3 times negative 3 plus 9, and negative 3 times I, negative 3i. And then lastly, we spread this negative I out to each of these 3 terms. We get negative I times x, which is negative ix, or negative xi. Negative I times negative 3, which is positive 3i. And lastly, and this is the one that most people mess up on, is we get negative I times I, which is negative, and we write I times I as I squared. And it's important to write it as I squared because we have a definition for I squared, and that is I squared equals negative 1. It's just a fact. Okay? So this little term right here is the opposite of a negative 1, or it's just a plus 1. Okay, so that's negative of negative 1, which is a positive 1. So now we can collect all of our like terms together and kind of clean this up a little bit. Let's see if we can find a nice color for it. Alright, so we've got an x squared term. That's the only term in that group. Here's a negative 3, positive 9, and something's wrong there. That is not a negative 3. Let me fix that. I noticed something right away. There shouldn't be that many like terms. This negative x times negative 3 is negative 3x. See if that looks a little better. So again, combining like terms, we've got our x squared. Now we've got negative 3x and negative 3x. That's negative 6x. Another important fact is this stuff. Here's a positive xi and a negative xi, so those cancel out. Here's a 9 and a positive 1, that's a 10, and a negative 3x, already took care of those, negative 3i, positive 3i, there's another cancel. So when I multiply this stuff together, it distributes out the negative to this, and then all of it simplifies to just that. And then the final step in this process is I haven't even messed with the x minus 2 yet. Remember, that just comes down. That has to be distributed to everybody. So we're distributing x. I get x cubed minus 6x squared plus 10x. Distributing the negative 2, I get, I'm going to write it in a convenient spot, negative 2x squared plus 12x minus 20. And adding up all my like terms, I get the final result, which is I have an x cubed minus 8x squared plus 22x minus 20. And that right there is the polynomial that has the solutions that we wanted at the very beginning. So I'm going to copy that and paste it back onto this page right here. So there's the final solution. This polynomial right there has 2, 3 plus I, and 3 minus I, all as solutions. And that will end the first recording.